Hey Sam, glad you could join us here and show us what this 2D camera is all about.
I'm always excited to show off these cameras, Oyvind.
Let's start on these warehousing applications. So for piece picking and parcel handling, the 2D image is really important for the robot to prioritize which objects to pick and so on. Obviously, the time it takes to get the 2D images matters a lot. So could you explain a little bit what we've done here to help our customers?
Yeah, we attacked this challenge directly. So with the 2+R, you get the 2D capture very fast. And this means that we can actually give the user the 2D capture before the 3D point cloud is even processed. And this is a huge head start for AI segmentation or template matching. That can get underway while we are wrapping up the point cloud. Then you can get on to pose estimating before you're even done the 3D capture. That's just talking raw speed. But there's also a lot of speed performance to gain in your cell if you have a high quality 2D capture.
Can you elaborate a little bit about what you mean when you say high quality 2D?
Yeah, absolutely. So in order for your AI segmentation to not make errors and be as accurate as possible, what you really want is for your 2D capture to be as close to the ground truth as possible. So there's sort of three challenges here. The first one is, can you resolve fine details? The second one is, can you get rid of these camera-specific artifacts? And the third and final one is, can you make it image-to-image stable across varying ambient light conditions? And we actually completely redesigned our 2D camera in order to combat all three of these challenges in a completely new way.
Fantastic. So can you show us?
Yeah, absolutely. So we have two of our models here. We have the Zivid 2 Plus M130, that's our older model. We also have the Zivid 2 Plus MR130, that's our newer model. So we have some difficult objects for high-resolution 2D cameras, and I'd like to show you a comparison between the Zivid 2 Plus M130 and the Zivid 2 Plus MR130.
All right.
And so let's go take a look here. Let's take a capture, show you that this is real. And when we zoom in here, you can see that we have these high-frequency radial lines. In particular, if you look at the M130 or older model, you see that we start to lose resolution as we move towards the center of this target. If we then take a capture here with the MR130, we end up getting extremely high resolution as we move towards the center of this target. It's limited only by the pixel pitch of the sensor. So what's important to note here is both of these cameras have 5 megapixel sensors. But with our clever redesign, the effective resolution of the MR130 is much higher. And so one thing that you'd notice is that really their ability to resolve fine details, it's tied with whether or not you have these camera-specific artifacts. For instance, in here, you can see that the debayering algorithm is leading to this sort of zipper effect, especially in various colored scenes. So we can look at other objects here. For instance, look at this deck of playing cards on the MR130. That is crazy. There's really high colored details here, and we see everything. We see the text. You can see the lines within the leaves here. It is greatly washed out when you look at it on a similar 5 megapixel camera. And then let's go and look at something maybe, I love these tee boxes, they're so colorful. We look at this tee box over here. What does our comparison look like on the MR130? Wow, that's just night and day. I mean, you could pick out these symbols here. You can pick out trees and leaves on the trees, and the colors are very strong.
And that's with 2 cameras that both are 5 megapixel.
Absolutely, yeah. Just a redesign of our camera.
And this is going to greatly help template matching algorithms to resolve different sort of textures that look similar and so on. That's why we're kind of looking at this, right? So
yeah, the underlying thread here is if we can give you a closer to ground truth image, then your AI segmentation algorithm, it doesn't need to work as hard. You don't need as many complex training sets, and you can identify key features much more easily.
all right, so you have shown us that this camera can produce some really fine detailed 2D images. But what about this image-to-image stability you were talking about?
I'm really glad you asked, because this is the fun part. Oyvind, if you may, can you go over here and control this light box here?
All right.
What I'd like to show you is as we increase the intensity of the ambient light, which is going to be from these 3 light sources, that the image stays extremely stable with our new 2+R model.
Okay.
So let's see. Right now we have very little light. I'm going to start live capturing. So this is the quality of our image. We can see there's some tiny amount of shot noise changing, so this is a real capture. Let's go turn up the lights.
All right.
Okay. So now I actually have a lux meter over here that says we are at 700 lux. That's way above what you'd expect in a normal warehouse. And look at this. We have great colors, extremely strong colors, and it looks almost identical to what we previously had before. So let's go all the way up.
All right.
Oh, I guess we're there. We're at 1600 lux. I didn't even notice because it looks so good on this film. Fantastic. So what I'm really showing here is that this camera is extremely robust to being in different warehouse environments. Whether you have one cell that has a little bit of lighting or another cell that has an extreme amount of lights, we're going to give you the same 2D image.
So what that really means is that a specific product or object, for example, that green box there, is going to look identical to two different robots in two different warehouses in two different lighting conditions.
Absolutely, and that's extremely important for AI segmentation because then it doesn't have to work as hard to give you the same result.
Are there any other sort of light intensity considerations that we should be aware of?
Absolutely. So the color temperature of your ambient light can play a huge role on what the colors are in your scene. So for instance, if I had a lot of orange or reddish light, then objects would end up being more red. So if my AI segmentation thinks my box is green, it better look green in my 2D image. And in fact, we can show that with a really fun example here. We have to bring the party.
Okay, so how do we do that? Yeah.
And so now we have an extreme version of color temperature varying in the scene. So we're going all the way from a pretty strong blue to a pretty strong red to a strong green. Actually, if we look at the lux meter, we're around 1,000 lux in almost all these scenarios. Yet this is our point cloud. So to prove that this is actually our point cloud, I can zoom in and we can see that there is some shot noise variation. We can perhaps look at these checkers and you can see maybe ever so slightly that the intensity is varying between the checkers, but not the color. What I'm showing now is that the camera is extremely robust to changes in color temperature across different warehouse conditions.
That's just incredible, Sam. Thank you so much for a fantastic demo. Is there anything else that you want to show us?
Yeah, let's take a look at the point clouds. Are they having a good time at this party? So we can come over here. Let's go take some 3D captures. So here, again, this is extreme lux values of 1200 lux, and we have beautiful point cloud coverage even across this varying color temperature scene.
So no changes to the 2D colors, no changes to the intensity, and no changes to the point clouds, including this transparent object that we got in here.
Absolutely, that's the power of our new 2D camera technology here.
That basically wraps up, Sam, how powerful this camera is, both from a 3D perspective and from a 2D perspective, with both from all this point cloud quality that we've shown, all the speed, and this ambient light robustness. The next thing we want to do is go over to Christian, who can show us how our customers can take this camera and get it up and running as fast and smooth as possible. So thank you, Sam, for the great demo.
Thank you for having me.